Okay, we're going to start section or unit 8, section 8.1. We're going to start by just going over a few definitions that are important to remember from your youth. So the first one is the diameter. It's the distance across the center of the circle. Okay, and then we move on to the radius, which is half the distance of the diameter. Okay, from the center of the circle to any point on the circle will be the radius. Okay, so this might be a new word, which is chords, a line segment that joins 2 points on a circle. So it doesn't have to be a special one, but just for trivia's sake, the diameter is actually the longest chord that we can find in a circle. So a chord is a line segment that joins 2 points. Okay, another new word is an arc. So that's just a segment of the circumference. So from point A to point B, we would call that the minor arc because that's the shorter of the 2 arcs between the 2 points. And this one on the outside here, it should be no surprise, we would call that the major arc. Okay, so just the section of the circle. Okay, other words that are going to come up in this unit are tangent. And a tangent is a line that intersects a circle at only 1 point. So it just touches the outside edge of a circle. So no surprise here that the point that it actually touches the circle we call the point of tangency. And that's going to be important. Okay, other new words, and we're going to go through these like section by section, but I'm just going to give you an overview of the vocabulary that you're going to need to be aware of. So a central angle, okay, is an angle whose arms are the radii, which is just the plural of radius of a circle. So here's the center of the circle. I drew one radius there. I drew another radius here, and what I create is something we call a central angle. And the way that I always remember that is central is like center, and this one starts at the center of the circle. Okay, so the other angle that we need to be aware of inside of a circle is called an inscribed angle. And that's an angle in a circle with its vertex and endpoints of its arms on the circle. So we start at 1 point at the edge of the circle, and then the arms just are 2 chords that cut across. Okay, so it doesn't necessarily have to be in the center. Okay, it touches, all 3 points touch on the outside of the circle. All right. So why did Mrs. Rosso make you do a whole bunch of work on the Pythagorean theorem and the interior sum of angles of the triangle? And that is because we are going to use those properties. Okay, so let's talk about the first one, which is properties of a tangent to a circle. If we have a tangent to a circle, okay, and it's perpendicular to the radius. So perpendicular is another very important word. Okay, so we have a center of the circle, we drew a radius, and this line here met at perpendicular angle. We're going to create a 90-degree angle, and that's really important, okay? So this one here is 90, this one here is 90. Why is that important? Well, if I drew a line from the center of the circle to point B, I've now created a right angle triangle, and we know that right angle triangles have special properties, okay? So just important right now at this point to remember that a tangent radius property, there's my dogs, okay, creates a 90-degree angle if this is perpendicular to the point of tangency. Okay, so for example, okay, we're saying that point O is the center of the circle and AB is a tangent, okay? We've created a 55-degree angle here. We want to know what this angle B is right here. Well, we know that this angle here, because it creates a 90-degree angle, so we can go 90, okay, angle O is 55. If we add those together, we get 145 degrees. Okay, so the 3 angles in a triangle, I have to add to 180, so we can go 180 minus 145. And so therefore I know that angle B has to be a 35-degree angle. So that's why we were reviewing a little bit of that. Okay, so if we tried these ones here, okay, so it says angle O is 42. I know that this has created a 90-degree angle. So you have to listen to that. So if I said 90 plus 42 is 132 degrees. I can take 180 and subtract 132 degrees. And angle D is therefore a 48-degree angle. Okay, same thing's happening over here. J is now a 90-degree angle. I know that that's a 14-degree angle. If I took 90 and 14, 104. So I can take 180, subtract 104. I'm going to do this the old-fashioned way. 76-degree angle. Okay, this gets a little bit harder now. Not a little bit harder, but we know that if we have a radius that touches a point of tangency, I've got a 90-degree angle on this side, 90-degree angle on that side. Okay, so I'm going to try and figure out what angle x is first. We'll do this in alphabetical order. So I know it's 90 and 57. So 90 plus 57 is 147 degrees. What's angle x? Well, I take 180 and subtract 147 from it. And you get 33 degrees. So angle x is 33 degrees. Now I'm going to do y. Same principle, just looks weird because we've snapped two triangles together here. 90 plus 35. Okay, 90 plus 35 is 125. I take 180 and subtract 125 from it. And you get 55 degrees. So angle y is 55 degrees. All right, next part of this section is using the Pythagorean theorem, okay? So we know we've created a 90-degree angle, we've got a leg, and we've got a hypotenuse. And the instant issue here is that we remember what the theorem of Pythagoras is. C squared is equal to a squared plus b squared, or if you like to write it, a squared plus b squared equals c squared, I'm a-okay with that. Label your triangle to keep yourself organized. So now I have 10 squared is equal to 8 squared, and now I'm going to solve for my unknown side. 100 is equal to 64 plus b squared. Subtract 64 from both sides, and this one's fairly straightforward. Last step is inverse operation, and the opposite of squaring something is finding its square root. So that side is 6 centimeters. So see, we can use the properties of the tangent to solve for sides and angles of a triangle. Okay, try this one. So here we go. We've created a 90-degree angle. This is C, this is A. So again, we're going to use C squared is equal to A squared plus B squared, and we're going to substitute stuff in here. Okay, I know that my hypotenuse is 16. I know that my one side is 12. So 16 squared, I'm going to get 256. 12 squared is 144. Take 256 and subtract 144, get 112. This one's not going to work out as beautifully. Through our benchmark skills, though, we know it's going to be around 10 because it's close to 100, so we just find the square root of that using a calculator, and you get b is equal to 10.6 centimeters. Okay. All right, so I just want you to watch this, and I'm going to post a really short little assignment.